All right, let's look at a problem now that's going to be very similar to question 3, which is kind of relating a function and a graph of its derivative. So if I have a function that looks kind of like this pink line right here, the question is, what in the heck does the derivative look like? So we need to kind of try and understand some things about derivatives and functions and how they're related. Let me just move this guy over a little bit here. So we'll move him over here, and then let's put our graph for our derivative out. And maybe what it might look like. So on the top is our function. On the bottom, we'll do our derivative. So this will be f prime of x down here. Okay. So when we're looking at these guys, what is really important to us is the slope of the line of the function. Okay? The slope of the line of the function is the y-coordinate for derivative. All right? So slope of the function, is the y-coordinate of the derivative. All right? So we can get a pretty good idea of what our derivative looks like just by looking at our basic function. So on our function, what we're going to have is we've got slopes, and if you'll notice right here, our slopes are all negative all the way to this low point, this minimum value right here. So all of our slopes come right around here. They're all negative, and they're gradually getting smaller until we get to that point right there. So somewhere right around in here, okay, our slopes equal 0 because we're going to have that horizontal asymptote there. So that means our y values are getting smaller. So what we could say is our graph has y values that are getting smaller. So we could say something like, and we don't know how it would look exactly, but something like y values are getting smaller all the way to the x coordinate right here. That would show our y values changing. And then right here, our y values go from negative to positive, and they're still positive all the way to this point, which is our maximum value right here. So we have positive y values at that point. So we would have a graph that would go, positive y values, but at this point they have to go back down. So, and again, we don't know how exact this is. We haven't talked about that yet, but it would do something like this. And then once we hit that peak, the slopes of my function change and are now negative. So my slopes now change and turn negative. So it would be, this is a possible graph, not maybe an exact graph of the derivative, but a possible graph of the derivative based on what we know. Okay, so slope of the function, the slope of your function is the y-coordinate of your derivative. Okay, and so when we do that, that's how we can graph these guys. And things that help, some things that help, are if we can figure out where our maximum values of our function are located and the minimum values of our function, where they're located. The reason those are important is because that tells us where we cross the x-axis with our derivative. Notice we have right here a horizontal tangent line, and a horizontal tangent line has a slope of 0. Okay, so it's a little bit confusing, but you can do it. It just takes a little bit of practice. But question 3 from your review, and there will probably be a question like this on your test, looks exactly and works exactly just like this.